Welcome to the Crazy Hat Chemist. So another video here on thermochemistry. So let's get moving. Bam! So today we're talking about a Hess's law calculation. So make sure you review the two previous videos on just what is Hess's law and some Hess's law hints on how to solve the problems. We're going to apply all those in this problem here today. All right. So the question is, what is the enthalpy change for the following reaction? That's carbon plus 2 hydrogen molecules gives me methane, that's CH4. Okay, we're going to solve for that. Okay, remember the puzzle pieces, and we're going to flip them, we're going to turn them, we're going to flip and turn potentially. Okay, or maybe do nothing at all and just put them right together. All right, so from a table in your textbook or the appendix in your textbook, you will find the following information. You will find these three reactions with their delta H's, that's enthalpy values in kilojoules. Okay, so you're going to find all this information. Somehow I need to work with these three equations and those numbers to get what I want. Okay, notice that all my ducks are in a row. Okay, I got the reactants on one side, the products on the other side, but vertically all my ducks are in the row. The separation between the reactants and products, that's very critical so that you can actually do the problem much simpler. Ultimately, we're going to add up these three reactions here, and we are looking for the delta H for the below reaction there. So that's what we're solving for. All right, so let's see how we can do this problem. Bam. So I got all the information that was on the previous slide right on this slide right over here. So this is what we're going to do. We got those puzzle pieces. We're going to put them together. Okay, the first thing is that we're going to put all our ducks in a row. Okay, so all the ducks are in a row. That is the vertical separation between the reactants on the left and the products on the right. Okay, ultimately what we want is this reaction, and we're solving for the delta H of this net reaction. We need to find a way to add up the three equations up above so that we get this net reaction. That net reaction is a carbon on the reactant side, 2 molecules of hydrogen on the reactant side, yields or produces CH4, which is methane. And from that, we are going to get the delta H for this reaction. All right, so what are we going to do? How do we approach this problem? Here's how we're going to approach it here. And every single one of these is a one-step approaching problem. Don't look at the whole thing all together. You need to look at each individual step. So just to highlight one thing, and here's what I'm going to do. I'm going to highlight just the hydrogen. So I got H2 that I want in the net equation that's on the bottom. The sum of all three of them is the net equation. Okay, I got hydrogen, and it's on the reactant side. And how many hydrogens do I have? I have 2 moles of hydrogen. So I need to look at the top three equations there and ask myself, where is hydrogen? And is hydrogen only in a single equation? It just so happens that hydrogen is right here in equation number 3. So now from that information, I need to ask the question, is hydrogen on the reactant side like it is on the net equation? Check, that's a correct. Okay, now is hydrogen have a 2 stoichiometric coefficient like in the net equation? Ooh, that's a no. So I need to do something to equation number 3 so that I get a 2 in front of the hydrogen. Okay, and so when I multiply equation number 3 by a 2, then that's what I will get, is that equation for rewriting it as 2H2 plus O2 yields 2 waters. Now, what do I do to the numeric value in kilojoules? So that negative 286, I'm going to multiply that by 2, and that's why I get the negative 572. Okay, so now I got the hydrogen taken care of. Now I'm going to look at something else on this equation. I'm going to take a look at the CH4. Now the CH4 in my net equation, that's the equation on the bottom, okay, that net equation has the CH4 on the product side, and it has a 1 stoichiometric coefficient. There's 1 mole of it that's being produced. So where is the CH4? The CH4 is right up here in equation number 2. Okay, now the CH4 in equation number 2 up at the top right there has the correct stoichiometry of a 1. However, it is on the incorrect side. So what we're going to have to do is flip the reactants and the products and then rewrite that. And that's what we're going to do right there. We're going to rewrite equation number 2 such that we flip the reactants and the products, but we've kept the stoichiometry as the same. So the question, what do I do to the negative 1? So what do I do to the negative 892 number. When I flip the equation, I multiply by a -1. So we're effectively changing the sign. So what is equation number 2 after flipped? It becomes a positive 892 kilojoules. All right, so now we got 2 of our 3 parts, and then we're almost done. So the last part is we're going to solve for the carbon. Now look at the net equation on the bottom that the carbon, it's on the reactant side. And there is 1 mole of it on the reactant side. Where are we going to find the carbon in the top 3 equations there? The carbon is right here in equation number 1. Now, equation number 1 at the top, okay, has 2 moles of carbon on the product side. I want 1 mole of carbon on the reactant side. So I'm going to have to do 2 things to equation number 1. I'm going to have to first flip the equation, and then I am going to have to divide by 2 or multiply by 1/2. One or the other as far as the math goes, it's the same. So I'm going to flip the equation, I'm going to divide by 2 or multiply by 1/2. What do I do to the positive 786? I'm going to do 2 things. I flipped it, that's multiplying by -1, and I multiplied by 1/2. I'm going to multiply that number by 1/2. So -1/2. What is -1/2 times 786? Bam, that's -393. Okay, now you should see that I have either flipped, multiplied, left them the same, whatever I need to do. Okay, so that now they do add up to this. Now, that very bottom equation is the net equation. I want to make sure that the rewritten equations 1, 2, and 3 truly do add up to what I want as the net equation, okay, before I add up the number. So I'm going to verify that that is the case. Okay, so just remember, when you're doing a math problem, if you have a 3x on one side of the equal sign and a 3x on the other side of the equal sign, they disappear, correct? So the same thing here is right here. I got 2 carbon dioxide molecules. In equation 1, one of them is on the product side, and equation 2, it's on the reactant side with the same stoichiometry of 1. So they cancel out, they're not in the net equation. What else do I have to cancel out? I have 2 waters. So I have, in equation number 2, I have 2 waters on the reactant side. Equation number 3, I have 2 waters on the product side. They both cancel out as well. Okay, now what else cancels out? Okay, now in equation number 1, I have oxygen on the reactant side. Equation number 3, I have oxygen on the reactant side for a sum total of 2 molecules or 2 moles of oxygen on the reactant side. Equation number 2 has 2 moles or 2 molecules of oxygen on the product side. All of those oxygens cancel out. And what remains that I haven't canceled out? Exactly what's on the net equation. That is a carbon plus 2 moles of hydrogen produces 1 mole of CH4. Now is the time in which I can add up the -393, the positive 892, and the -572. And there I get the -73 kilojoules. This net reaction right here is exothermic because that's a negative value. Hopefully that makes sense for you. Okay, simple problem. Just do it one step at a time. Remember, it's a simple puzzle. Keep your ducks in a row. Make sure you follow the rules. Flip the equation, multiply by a negative. Leave it alone. Don't do anything. If you multiply by a fraction, then multiply by a fraction. All right, I got another crazy hat here for you, and this one is a chicken. Give me a thumbs up if you like that video. Subscribe to my YouTube channel. Find my website online. There's lots of reinforcing worksheets just for your pleasure of chemistry. Pass on my stuff to everyone you know. Bye for now.